This is the first example from 4.7 part 2 that we're going to cover in the videos, and we're going to talk about what we probably have been building up towards the whole time, and that is the fact that we're using trig inverses means that an inverse and its original function kind of undo each other. And so what we're going to take a look at here is some examples where that happens. This is a little bit buried in your text, and so I would really recommend that you write this stuff down, that you write these rules down, because this will help out a lot when thinking about the regular and the inverses, how they undo each other. Now, one thing you need to pay particular attention to here is notice the fact that the regular trig functions are on the outside, or the predominant factor in this case, and so this only works when we're going in this direction. We're going to see the opposite direction in the next example. But it says here that these things are true, that sine and inverse sine, they undo each other, and they're always true as long as they're defined. Now let's remember what it means for something to be defined. Sine inverse of x, in order for this to be defined, it means that whatever x is has to fall within the domain. So as long as this number falls in between those numbers, then it is defined and we can use this rule, and they just cancel each other out. So let's take a look at these three different examples and see if we accomplish that. First of all, the sine of the sine inverse of 1/2. So we have sine inverse of 1/2. We start on the inside and we just examine that. Does the 1/2 fit into the domain of sine inverse? Well, 1/2 is certainly between -1 and 1, so yes, it does. That works. If that's the case, the sine and the sine inverse simply cancel out and we get 1/2. That's all there is to it on a problem like that. Same goes for the other examples. Tangent and tangent inverse. We have tangent inverse of 2.3. Well, the tangent inverse domain is everything, so that definitely works. If that's the case, tangent and tangent inverse undo each other, and we just get 2.3. This last one you probably already guessed and has a little bit of a catch to it, and it does. Cosine of cosine inverse of 13/12. Now 13/12, if you punch that in your calculator, you'll notice that that's just slightly over 1. Cosine inverse has a domain of -1 to 1, so this would lie slightly outside of its domain. That means that this is not defined, and so that one can't be done. But we have these two. The inverses undo each other, and we just get whatever is inputted as the output.